Hello students, welcome to the second lesson, chapter 11, three-dimensional geometry. In the first lesson, I have given you the idea of basics of 3D geometry, direction, cosine, then direction ratio, and other related concepts. And I also made it very clear to understand three-dimensional geometry, the clear understanding of vector is necessary because we are using the concept of vector now and then in the proof also. Therefore, please revise vectors before starting three-dimensional geometry. Let us study three-dimensional geometry further. Here, in this lesson, we are studying the equation of lines in space. Let me make one thing very clear in the beginning. In first PUC straight lines, we have studied straight lines in two dimensions, that is on a coordinate system with the x-axis and y-axis. Whenever we want to study straight line in two dimension, the first thing which you have to remember is slope of the line. That is the basic concept required for deriving the equation of straight line. Of course, then we studied equation of straight line in different forms. I think about 6 to 7 different forms we have studied. For example, slope point form, then intercept form, then y-intercept and slope form, then 2-point form, etc. Normal form and general form, so many different forms. But here in space, there is no concept like a slope because there it is only x-axis and y-axis, and the angle which the line makes with the x-axis, that we have taken as the standard, and then we define slope. But in case of three dimension, the line can cut x-axis, y-axis and z-axis, sometimes only two axes, sometimes only one axis. So these are the possibilities. Therefore, what happens is we cannot take the concept of slope here. We have to study the equation of the straight line in a different way. But here there are only two possibilities, equation of straight line. Let us study them. Equation of line in space. A line is uniquely defined in the following ways. One is, a given line can pass through a given point and parallel to a given vector. This is one important concept. Let me show you with the help of a diagram. Consider a line L in space. This line L can pass through the given point A, x1, y1, z1, and then it can be parallel to a given vector B. So this is the first possibility. So only two different ways we can understand the line in space. Second possibility is it passes through two given points. For example, you take a line L and then let us say A x1 y1 z1 and B x2 y2 z2. These are the 2 points on the line. Then also we can find the equation. The first case, equation is given like this. Vector r equal to vector A plus lambda times vector B. Here r is the coordinate of any point on the line and A refers to the position vector of the point A, that is x1, y1, z1. B is the vector which is parallel to the given line. So this is the idea. And the second one is, we can also find the equation of the line in vector form. Vector r minus A equal to lambda times vector r minus vector B minus vector A. So this is a second one. So these are the only two types of equations. Let us proceed. Let us derive them separately, that is first case as well as the second case. First one, the equation of line passing through given point A x1 y1 z1 and parallel to vector B. We can take it as a theorem. The theorem can be stated like this. The equation of line passing through a given point A x1 y1 z1 and parallel to vector B is given by vector r equal to vector A plus lambda times vector B. Vector A means here it is the position vector of the point A x1 y1 z1. Of course, vector B is parallel to the given line. Let us prove it. Consider a rectangular coordinate system. Let L be a line passing through the given point and parallel to the given vector. So you can show the diagram like this. L is the line and B is the vector parallel to the given line. Now let the position vector of A be x1, y1, z1. Let us take it as A, vector A, that is the position vector of the point A. Now what we have to do is, let us take one more point P, x, y, z, which is on the same line anywhere. It is other than A, and with position vector R. Position vector R. So this point P is the point and whose position vector is R. So let us join now OA and OP. Now look here, AP is parallel to B. It's very clear because vector B is parallel to the line. A and P are the 2 points on the same line, and we have joined OA and OP, and we have also assumed that A is the position vector of A, R is the position vector of P. Therefore now we can definitely find AP vector, and AP is parallel to the given vector B. So this is the thing. Now this property we have studied in vector. Therefore I made it very clear. Proper understanding of vector is necessary. Vector AP is equal to lambda B because vector AP is parallel to B. This is one of the important properties of vector. Now what we have to do is, we know the formula. AP can be written as OP minus OA, that is equal to lambda B. So this is also property we studied in vector. Now substitute. OP is R and OA is A. Therefore R minus A equal to lambda times B. That is vector R minus vector A equal to lambda times vector B. This is the equation of the line, or we can take A right side. Therefore vector R will be equal to vector A plus lambda times vector B. This is the proof of equation of the line in vector form. We have to prove the same thing in Cartesian form also. Let us proceed. Cartesian form. Consider R equal to, that is vector R equal to vector A plus lambda times vector B. Now R equal to, let us take xi plus yj plus zk, because point P is R and point P coordinate can be taken as xyz. Similarly, A is x1, y1, z1. Therefore A can be taken as x1i plus y1j plus z1k. And B is of course a vector parallel to the given line, that we will take as AI plus BJ plus CK. That means A, B, C are the components of IJK. Now we know that R equal to vector A plus lambda times vector B. So therefore substitute. R is taken as xi plus yj plus zk. Right side, A is x1i plus y1j plus z1k, and lambda times B equal to AI plus BJ plus CK. Now what we have to do is take the vector A left side. Therefore xi plus yj plus zk minus x1i plus y1j plus z1k, that is equal to lambda times AI plus bj plus ck. Now you can simplify further. You can collect the components together, x minus x1 with I, y minus y1 with j, z minus z1 k. So that is equal to lambda A times I, lambda b times j, lambda c times k. You are taking lambda inside. Now there are two vectors. At this stage you have to understand x minus x1i left side and lambda a I right side. So the corresponding components must be same. So this implies x minus x1 must be equal to lambda a, y minus y1 must be equal to lambda b, and z minus z1 equal to lambda c. This property also we have studied in vector. So now this implies x minus x1 by a must be equal to lambda, y minus y1 by b equal to lambda, z minus z1 by c also must be equal to lambda. Therefore equating them you get x minus x1 by a, y minus y1 by b equal to z minus z1 by c. This is the Cartesian form. So the first one is vector form, second one is Cartesian form. Now let us take one example. Find the vector and Cartesian equation of the line passing through the point 5, 2, minus 4 and with the parallel to the vector 3i plus 2j minus 8k. So what is given here? We have vector A equal to 5i plus 2j minus 8k because the point is 5, 2, minus 4. and it is parallel to the given vector b. We have to take 3i plus 2j minus 8k. Now you know that equation of the line in vector form is vector r equal to vector a plus lambda times vector b. Therefore substitute r equal to 5i plus 2j minus 8k plus lambda times 3i plus 2j minus 8k. So this is the answer. Now x1 y1 z1 is 5 2 minus 4 and abc is 3 2 minus 8. Therefore equation of the line is x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c. Substitute. So x minus 5 by 3, y minus 2 by 2 equal to z plus 4 by minus 8, because it is minus 4, so minus of minus becomes plus. So this is the Cartesian equation. Normally you will be asked to find the equation in both form, vector form as well as Cartesian form. Second one is now equation of the line passing through two given points. So this also can be taken as a theorem. The equation of the line passing through two points whose position vectors are a and b is given by r equal to a plus lambda times vector b minus vector a. So let us consider the rectangular coordinate system. Now let L be the line passing through 2 points A and B. So we can take the line L with 2 points A and B. Let us say OA equal to vector A, that is the position vector of A is vector A, and position vector of point B is vector B. Now join them. So now this is important. Let P be any other point on the line with position vector R. So other than A and B, you take any point. For example, P is the point with position vector as shown in the diagram. So position vector is R. Now you see here vector AB, this is on the same line, that is equal to OB minus OA. By definition, this is a formula, that is vector B minus vector A, that is position vector of end point minus position vector of initial point. Then AP vector also you can take, that is OP minus OA, same formula, so it is vector R minus vector A. Now look here in the diagram, vector AP is parallel to vector AB because both vectors are on the same line and in the same direction also. Therefore now this implies vector AP must be equal to lambda times vector AB, property of the vectors. Now once again, what is AP? AP is vector A minus vector R minus vector A equal to lambda times vector B minus vector A. Therefore simplification will give you vector R equal to, that is take minus A right side vector. So vector A plus lambda times vector B minus vector A. This is the vector form of the straight line or equation of the line in vector form. So this you have to remember. So here the condition is that line passes through 2 points A and B. Position vector of A is A, position vector of B is B. This is the vector form. Let us proceed. Cartesian form. Now what you have to do is R is xi plus yj plus zk. Position vector of P is R and component we have to take xyz. It is any point. A is x1i plus y1j plus z1k, that is position vector of the first point A. B is x2i plus y2j plus z2k. This we have seen in the diagram also. Substitute in the equation. So what happens is R equal to A plus lambda times vector B minus vector A. Substitute. Left side, vector R equal to xi plus yj plus zk, and that is equal to vector A is x1i plus y1j plus z1k plus lambda times, then B minus A is x2 minus x1i, then y2 minus y1j plus z2 minus z1k. So then as before you can simplify like this, take the vector x1i y1j plus z1k left side and simplify. That will give you x minus x1i, y minus y1j, z minus z1k, and that is equal to right side lambda times x2 minus x1i plus y2 minus y1j plus z2 minus z1k. So equating the like coefficients of I, j, k as before, we get x minus x1 will be equal to lambda times x2 minus x1. Similarly, y minus y1 will be equal to lambda times y2 minus y1, and z minus z1 will be equal to lambda times z2 minus z1. Therefore, we can get x minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1, that is equal to z minus z1 by z2 minus z1. I have reduced one step. Actually, each one will be equal to lambda, but lambda I have not written. Directly I have written the last step. So this is the equation in Cartesian form. This is the equation in Cartesian form. First one is vector form. So normally you should remember both forms, vector form as well as Cartesian form. Let us take one example. Find the vector equation and the line passing through the point minus 1, 0, 2, that is the first point, 3, 4, 6, second point. So solution, A here is, we have to take minus I plus 2k because 0, j component is 0. Then B is 3i plus 4j plus 6k. Now you know this one. B minus A also you can calculate first. So B is 3i plus 4j minus 6k minus A. The separate step is not actually necessary, but I have shown it like this: 4i plus 4j plus 4k after simplification. Now what is the equation of the line? That you have to write. Vector r equal to vector A plus lambda times vector B minus vector A. Therefore substitute. Vector r will be equal to minus I plus 2k plus lambda times 4i plus 4j plus 4k. This is the vector equation. Of course, question it is not asked to find the Cartesian equation. Even if it is asked, you can find using x minus x1 by x2 minus x1, etc. So this is the second form. Example 2. The Cartesian equation of the line is given x plus 3 by 2, that is equal to y minus 5 by 4, that is equal to z plus 6 by 2. Now what is asked is find the vector equation of the line. As I told you in the beginning, sometimes vector equation is given, you have to find the Cartesian equation. Cartesian equation is given, it can be converted into vector also. So here we have to understand this one. What is given is x plus 3 by 2 equal to y minus 5 by 4 equal to z plus 6 by 2. Now comparing with this equation, what is the Cartesian form? X minus x1 by A equal to y minus y1 by B equal to z minus z1 by C. Therefore definitely x1 is minus 3 because x minus x1, there it is x plus 3. Then similarly y1 is 5, z1 is minus 6, and A is 2, B is 4, and C is 2. Therefore now substitute. Therefore equation in the vector form is what? R equal to A plus lambda B. So substitute, that is vector R equal to A. Vector A is 3i plus 5j then minus 6k plus lambda times then 2i plus 4j plus 2k. So this is the vector equation. So this is second example. Thank you for watching this video. Let me conclude. We have taken two different forms of equation. One is line passing through one point and parallel to a vector. That is number one. Second one is line passing through 2 points. You have to remember both form, that is vector form as well as Cartesian form. Hope you have subscribed my channel and watching all the lessons. If not, please subscribe and share with your friends. I will be uploading all the lessons. As I made it very clear, preparation of lesson takes a lot of time because now I have shifted to PPT mode because that will be more clear. I can show the animation and other things so that concept might be made very clear. So I find it is more convenient for the student. Earlier I was using blackboard method, but now I have shifted to PPT presentation because here it will be very clear and I can show all the diagram in a very neat way so that it is convenient for the students also. So it takes more time, but I will be definitely uploading all the lessons without leaving anything. Please follow me and encourage me by subscribing and sharing with your friends. Let us meet in the next lesson with some more examples on these two types. Let us proceed. Till then, bye, take care.